Okay, we're going to start lesson 6.1 today with the start of a new unit. And as we stick around in our three-dimensional figures, we just came from unit 5 where we did volume, which was measuring the inside three-dimensional space. Now we're going to talk about three-dimensional area. How do we calculate the area that goes all around these three-dimensional polyhedrons? All right, so we have some vocab words that we sort of already know. One of them would be the bases. So the bases are, as we can remember, the congruent, parallel. We called them faces in Unit 5. But it's okay just to think of them as sides. Congruent, parallel, faces, or sides. We know the height is that distance between the bases. Lateral area is going to be the area of all lateral faces. Well, what does lateral mean? If we look down here, a lateral face, it just means, and I'm going to use a little bit more informal way of writing this. If this was a room, it would be all the walls. The floor and the ceiling, those would be the bases. So I'm going to come back up here and write. Floor and ceiling, and the walls. Now we remember in the last unit we talked about it doesn't have to be the floor and ceiling. Maybe this thing got pushed over and it's really on the left and the right or the front and the back. The surface area is where it all comes together. Area of lateral faces and bases. So it's everything together. One thing I want to point out down here, we used the word height a lot last unit. Altitude is the same idea. This is a good way of saying the height, but in something we call it oblique where it's leaning, now the height is right here. So we call that the altitude. The altitude covers both of it. You guys will see these a little bit more. You're not going to see too many obliques. All right, lateral area. If I was to find the lateral area, remember it's all of the walls. So that means that's one of the walls. And how would we find the area of that green wall? Well, that would be length. I don't like the way I'm writing that. Length times height. Make that a capital L there. Because this is height. So that's just a rectangle. That's L times H. And now if I come back here, this is going to be W times H. And if I go in the back here, that's going to be the same as the front. So again, that's L times H. And if I go back here on the side, that's going to be the same as the purple one, which is W times H. If you look at that, what is reoccurring in all of them? It's H. So I'm going to pull an algebraic move here, and I'm going to factor out that H, meaning I'm going to take the H out of each of them. And let's just bring it out front. And what's left inside? L plus W plus L plus W. When I add these all up, before I multiply them by that height, what measurement is this? L plus W plus L plus W. That's just the perimeter of the base. It was just a long way for us to get there. So the formula for lateral area is LA equals perimeter times height. We'll call it capital H. It almost looks like volume. Volume was B times H. Lateral area is P times H. What about surface area? Well, surface area is the lateral area. Actually, let's write it like this. It's that same lateral area, but now what are we going to add on? We're going to add on the top and the bottom base. Because we got all the walls, now we have to put on the floor and the ceiling, which is L times W plus, that's the bottom, here comes the top. But that's just for a rectangle. That's just for a rectangle here. What if it wasn't a rectangle? We can't just say L times W, because right here we're just saying lateral area. So the formula we're going to use is lateral area plus the two bases. And here comes the same capital B from last unit. Remember when we had to find the base, the area of the base for volume? That's the same exact capital B. So everything we did last unit is going to show up here again. This is important for us to be able to understand. When in doubt, we are just finding the area of every single touchable side. So I could touch the top, bottom, and all the way around. If I was to unfold this, we call this a net. We would see the 3x4 bottom rectangle, which is the same up top, right here and right here. And then all the walls going around, you'll see it in the middle there with the 4 rectangles. So feel free to go ahead and figure it out one at a time, but we are going to do it using the formula. So surface area equals lateral area plus both of the bases. So surface area equals, remember lateral area is the perimeter of the base times the height plus 2. Now what is capital B? Since it's a rectangle, It's going to be length times width. Just like we did for volume. So surface area equals the perimeter. So I'm going to start putting in my open parentheses here. The perimeter is 4 plus 3 plus 4 plus 3. The height is 5. And the base is 4 times 3. So the surface area equals 14 times 5 plus 2 times 12. You guys can speed that process up as much as you want. That's 70 plus 24, so that's 94. And that's area. So that's going to be centimeters squared. So what we just did was we said 3 times 4 is 12, 3 times 4 is 12. This is 5 times 4 is 20. This is 5 times 3 is 15. 5 times 4 is 20. 5 times 3 is 15. We added those all up. Here's the 70. Here comes the 24. So lateral area, one more time. Formula, perimeter times the height. Surface area is the lateral area plus the 2 bases. I better put in here perimeter of the base. So over there is the perimeter of the base. On the other side, we have area of the base. So let's go ahead and try this again. Again, the base is important, just like last unit. There's the base. So lateral area plus 2b, that's how we're going to find that surface area. Lateral area is going to be the perimeter. You can compare how I'm doing it this time compared to how I did it last time. I'm just going to break it apart. I'm going to find the lateral area. I'm going to find capital B, and then I'm going to bring it all back together. So lateral area is P times H, which is 9 plus 7 plus 9 plus 7. My stylus is starting to lose it on me here. Times the height, which is 14. So that's going to be 32 plus 14, which is 46. Capital B is going to be 9 times 7, which is 63. So surface area is 46 plus 2 times 63. And the reason we're doing 2 of them is because we're 46 represents all of the walls. 63 represents the bottom. We need another 63 to cap the top. So that's 126. What's that? 172, I believe. Yep, 172. Square feet. Right, this is not rectangular. This is a triangular prism. The base is a triangle. So we're going to start with surface area equals lateral area plus 2b. Lateral area is perimeter times the height. Looks like I have some numbers missing on here for us. Let's go with 15, 9, and 13. So the perimeter is 15 plus 9 plus 13. The height is 12. So 15 plus 9 plus 13 times 12, we get 444. Capital B, well, since it's a triangle, is going to be base times height divided by 2. So that's 15 times 8 divided by 2, which is 15 times 4, which is 60. So surface area equals 444 plus 2 60s, which is 120. So that's 564 square centimeters. All right, a composite. Remember before, if it was volume, we found the volume of the top and the bottom, and we added them together. Similar here, there's going to be one little catch here, though. The bottom, surface area, equals LA plus 2B. So LA plus 2B. Let's go ahead and find LA. I'm going to do it in purple. Try and color code this a little bit more than last time. Is perimeter times the height. Perimeter is 4 plus 2 plus 4 plus 2. That takes me around the bottom. And we're going to multiply that by 3. Which is 36. Capital B is going to be 4 times 2, which is 8. So the surface area equals 36 plus 2 times 8, which is 36 plus 16, which is 52. So that's the bottom. Now let's do the top. Surface area equals LA plus 2B. We'll do LA in purple, B in green. So LA equals perimeter times the height. The perimeter of that triangle is 3 plus 4. Pythagorean theorem would tell us that that is 5, but we're going to avoid that right now. I'll give that to you. So 3 plus 4 plus 5 times the distance between the two triangles is 2. So that's 24. The base is going to be little b times little h divided by 2, which is 3 times 4 divided by 2, which is 6. So surface area equals 24 plus 2 6s, which is 36. So the total surface area is going to equal 52 plus 36 minus, and here's why we're going to subtract something. We just calculated every touchable surface as if these were two separate shapes. These two shapes are glued together on those matching rectangles. That rectangle that I just colored in belongs to the top and it belongs to the bottom. We calculated that rectangle 2 times. And that rectangle is a 4 by 2. So we need to subtract it out twice. So we always need to subtract out twice where these shapes are glued together. So 52 plus 36 minus 8 minus 8. So minus 16 gives us 72 square centimeters. All right, number 6 is actually going to be the exit ticket for today. I'm going to get you started, so let's see who watches the video to the end and then complete the exit ticket. So we're going to go blue, purple, red. So surface area for the blue is going to be lateral area plus 2b. There's going to be your base. So LA is going to be P times H, which is going to be 7 plus 7 plus 7 plus 7 all the way around that top blue square. And then the height, it's a cube, so it's another 7. So that's 28 times 7, which is 196. Capital B is going to be 7 times 7 because the area of that blue square is 49. So surface area equals 196 plus 2 49s which is 294. All right, I'm just going to set up the rest. I'm not going to complete it any further, though. I'll talk through it at least. You need to do the same thing as we did with the blue, but do it for the purple. And then for the red, we have a base that's a triangle. So down here, the purple is going to be your base, 21 by 7. So here you have a 7, 21, and I'll help you guys out there real quick with that. So we're going to make that to be, let's see here, I want to make sure I'm using the same numbers that I have for the exit ticket. Just want to be accurate here. Let's go with 53. I just got that with the Pythagorean theorem, trying to avoid some of that complex work with you guys right out of the gate. So with that 53, you can now find the perimeter of that red triangle, and you'll need that. So next, you should have surface area. And then you need to do it for the red as well. And then don't forget, you're going to be adding up the surface area for the blue, the surface area for the purple, and the surface area for the red, but you will need to subtract where they're all glued together. So you'll need to subtract this green area twice, and you'll need to subtract this yellow area. Oops, that's not yellow. You'll need to subtract this yellow area twice. So I'm going to break this up into a couple parts. I'm going to see if you, one, can tell me what the surface area of the blue is, even though we just did it. the surface area of the bottom purple, the surface area of the red triangular prism, and then if you can tell me what the whole thing is all together for surface area. All right, go ahead and attempt that exit ticket. The homework now is not, I don't have booklets put together for you guys anymore. We've kind of paced what I had prepared before we left the building. So you'll start seeing inside each daily folder the notes section by section. And same thing with the homework. The homework will be in there on its own as its own PDF. Make sure you guys get in touch with me with any questions. You guys know my office hour times, or feel free to email me or message me on the Google chat.